Section 2.3, deductive reasoning. Again, we are going to work on some deductive reasoning pieces, and in this particular lesson, we are going to talk about the law of detachment and law of syllogism, which is logic chains. And then we're going to review inductive and deductive reasoning and the differences between them. So remember, we talked about this before. Deductive reasoning is the process of using facts, definitions, accepted properties, and the laws of logic to form a logical argument. This is different from inductive. Inductive reasoning uses specific examples and patterns to form an educated guess on what might happen next. And then the law of syllogism is also known as our logic chains, our if-then statements all joined together that are all related. So let's first talk about the law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. So I'll show you some examples here. Use the law of detachment to make a valid conclusion to the true situation. This is kind of the key here. It has to already be a true situation. So if two segments have the same length, then they are congruent. We know that that is true by definition. So now it says you know that BC is equal to XY. So remember, capital B, capital C is saying the distance between points B and C, or the length of segment BC, is equal to XY. So what I conclude is, so then segment BC is congruent to segment XY. So I had a true statement, and now I have a specific case for that true statement. Here's another example. If Nathan is enrolled at RHS, then he has a student ID number. That's a true statement. Every RHS student has a student ID number. So Nathan is enrolled at RHS, so then Nathan has a student ID. Number. All right, so law of detachment. Now let's look at the law of syllogism. These are also known as logic chains. In some situations, it's not enough to make proper conclusions based on only one conditional statement. Instead, what if we are provided with multiple conditional statements that are all related to each other? Could we make a valid conclusion based on a very different hypothesis? So here's an example. If Joe takes geometry this year, then he will take algebra 2 next year. If Joe takes algebra 2 next year, then he will graduate. What conclusion can we make? Well, Joe takes geometry, then he takes algebra 2. And because he took algebra 2, then he will graduate. So our conclusion would be, if Joe takes geometry this year, then he will graduate. So we put these together and take the original hypothesis and the final conclusion. So officially, when you have multiple related conditional statements, you can put them in a logical order. When that is completed, you take the hypothesis of the first conditional statement and then take the conclusion of the final conditional statement and put them together to make a final conditional statement. And in that last case, we only had two conditional statements. Let's look at another example. It says, write the final true conditional statement based on the logic chain. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A. So again, here was our original hypothesis, and it led to this conclusion. And that conclusion right here now became our next hypothesis, leading to this conclusion. So you could kind of think about it is, if this was P, then Q, and then Q leads to R. So now we have then P leads to R. So that might be another way to look at it symbolically, but how we would write this final conditional is we take the first hypothesis in order. If Rick takes chemistry this year, so that's our original, then Rick will get an A in chemistry. Now, these conclusions were fairly straightforward, but sometimes they get kind of illogical or really strange. So let's take a look at this one. It says, if it is cold, then birds fly south. If the days are short, then it is cold. If it is winter, then the days are short. This is all a mess, okay? Because in logic chains, the first hypothesis has to lead to a conclusion. And that conclusion then becomes the next hypothesis. So we need to put these in order. So you have to figure out the order for these first. So see if you can do that. See if you can pause the video and see if you can figure out which of these statements comes first, second, and third, and then number them on the side. Start the video back up and see if you got them correct. So in order, if it is winter, then the days are short. That would be our first conditional statement, leading to that conclusion. Now, that conclusion right there, if the days are short, right here, that leads to it is cold. So now it is cold has to be our last conditional leading to this. So when they're in order, we read it, if it is winter, then the days are short. If the days are short, then it is cold. And if it is cold, then the birds fly south. So our final conditional would be our first hypothesis, if it is winter, then birds fly south. So always make sure that you put them in order so it flows from one to the next. Here's another one. Again, you see if you can put this in order, write the numbers next to them of the statements that would come first, second, third, and fourth. Pause the video, see if you can do that, and then start it again to see if you got them correct. So, in order, if you clean your room is your first hypothesis. Then you will go to a movie. If you go to a movie, see, this has to be your next hypothesis. If you go to a movie, then you will spend all of your money. If you spend all of your money, then you cannot buy gas for the car. And if you cannot buy gas for the car, then you will be stranded. So our final conditional would be, if you clean your room, then you will be stranded. So again, sometimes they seem kind of illogical and kind of silly at times, but that's what we do with law of syllogism, is we put all of the conditional statements in order, and then the first hypothesis and the final conclusion become your final statement. Sometimes we can write them in terms of math, okay? So if y cubed is equal to 8, then y equals 2. If y equals 2, then 3y plus 4 equals 10. So again, we take this first conditional, or first hypothesis, if y cubed equals 8, then, and we pair it up with the final conclusion, in this case only two conditional statements, then 3y plus 4 equals 10. All right, so we did this one yesterday where it says use inductive reasoning. Remember, that is specific examples to make a conjecture about the sum of a number and itself. and then use deductive reasoning to show that the conjecture is true. And remember, deductive reasoning is using facts and definitions and properties. And we went through this yesterday, I believe it was, or earlier. So now see if you can do this. Give it a shot. And then look back to the notes and see if you got it right. It's just good practice. Same is true with this. See if you can decide whether inductive or deductive reasoning is used to reach these conclusions. Remember to have a reason why, because that's kind of key. Sometimes it might be, could potentially be either inductive or deductive reasoning, kind of like when we looked at the Sherlock Holmes clip. Maybe that was more of a logic chain at times, but regardless, I'd like you to give this a try and then check back to the notes from the other day and see if you got it right, or you could watch the video again. So here's our final little piece. We're going to just, as a little review here, this is what we kind of talked about today. The law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. Okay, so remember, you have to have a true conditional statement for the law of detachment. And then you make a valid conclusion to that true situation. So it allows you to make a valid conclusion to a true situation. So usually it gives you a new hypothesis, like a new specific example for your hypothesis. And then you come up with the conclusion. Okay? Law of syllogism, logic chains, allows you to write a new conditional statement that follows from a true set of statements, conditional statements, in order. So that is the end of our 2.3